Hi there everyone. So this week we're going to do Ohm's Law. So you log on to Canvas, you click on Modules, scroll down and click on Ohm's Law, this PDF file, and the data which I will open it when it's available. So you should download your data from the lab data folder, and the recording for this one will be uploaded to lab instructions, recording in additional files. All right, so when you click on the Ohm's law, so let me stop sharing and open the file. Let's see. All right, so what is the purpose of this experiment? You'll be given different electronic devices, and you want to determine whether it obeys Ohm's law or not. So what exactly is Ohm's law? So Ohm's law, in some, in essence, can be represented by this figure. So this figure shows the voltage across the electronic device, and the current is through the device. So when you measure the voltage across the electronic device, and measure the current through that device, and you plot voltage versus current, and you're going to find that it's going to form a straight line. If this forms a straight line, indicating that this obeys Ohm's law. So in other words, the ratio of voltage to the ratio of voltage to current is a constant, then this kind of material obeys Ohm's law. Now, instead, if you do, if you have voltage and current data and you plot voltage versus current, and you did not find a straight line, you actually find, any curve that does not have a linear relationship, then this kind of material is called non-ohmic. And so, and in addition to that, when you plot voltage versus current, the slope, when you do the line fit and you find that there's a slope, and that slope is the experimental value of the resistance, because we know that V equals IR from activity 2. So R is equal to V over I. And so this is how you determine the resistance of ohmic material, just by doing that. Now, what about when you have a material that is non-ohmic? In other words, it is the relationship between voltage and current is not as simple as a straight that can be described by a straight line. Then you would use this equation. You use dV over di. So in other words, instead of measuring a broad extent, you would just focus on the local resistance, and that resistance can change from one value to another because you're doing the dV over di. Okay, so in other words, for non-ohmic material, the resistance value would not be a constant, but for ohmic material, the resistance is a constant. Okay, so so you'll be given 4 different material. One is a resistor, the commercially available resistor that has a resistance value of 330 ohms. You'll be given a light bulb. You're given a diode, and also the bicolor LED, and then you're going to construct your circuit, and then provide a voltage to the electronic devices, and then you measure current. You measure current through a device, and you measure the voltage across the device. And based on the data that you gather, you can plot voltage versus current in order to determine whether that material obeys Ohm's law. Is ohmic or non-ohmic? And if it is ohmic, what is the resistance? Okay. All right. So take for example this one. This is when you have when you have a resistor. So this is an electronic board. So these two connected to power supply, and you have the resistance that is right here. Okay, so you need to construct your circuit. You need to insert your ammeter in the circuit, and then use the alligator clips to click on this 2 springs to measure voltage. So this being the positive, so the positive is connected to the positive of the ammeter, and this is the COM from the ammeter, so it's connected to the spring. So you can see that your ammeter becomes part of the circuit, And then this side is going to connect it to the positive of the voltmeter, because it's positive is always close to the positive, and the comb of the voltmeter will be connected to this spring so that it is across this resistor. So this is the resistor. It has two leads. This one is connected to this, and then this one is connected to that. And then you need one wire lead to complete the circuit. So you can see that when current goes through, it will come from the positive power supply and going through the emitter, and it's going to register the current, and it's going to go through the resistor, and also there's a current go through the voltmeter, and through that the voltmeter can measure can register the voltage, and you need one wire lead to complete the circuit. Okay, and you will do the same thing for light bulb. So this is the locations of the light bulb. You can see that this two connect to the power supply. One, one cable connect to this, and one connect to this spring, and then from the for the voltmeter, it is like two over here, and then you one wire lead to complete the circuit. Okay, so it's basically how you do it with the when you want to measure voltage and current simultaneously. And of course, the next two figures shows how you, when you have a diode, so you can't really do a diode directly, so you have to connect a diode to a resistor, and then again you can see that this is the emitter that is being part of circuit, and then you have the resistor, and then you have the voltmeter. Now we're not using the voltmeter to measure the voltage across the resistor. Instead, we're using the voltmeter to measure voltage across the diode. So these two cables will be connected to the two leads of the diode, and then you need one wire lead to complete the circuit. At the same time, also you should have one wire lead connected to this two springs so that the whole thing is connected. And of course, the same thing for the LED bicolor LED. So that's how you connect the circuit. So the experimental itself is very easy to do. Basically, you construct your circuit, and the power supply you will change from -5 volts all the way to positive 5 volts at the 0.5 volt increments. And then you're going to use a voltmeter and ammeter to measure voltage and current. And so you would do the same thing, repeat the same process for the other three electronic devices. And for light bulb, you can see that it does not have a constant, let me see. For light bulb, you're using a smaller voltage increment. You're using 0.25. And because the light bulb has a voltage limit under 3 volts, so we use from -2.5 all the way to positive 2.5. And for the diode, you can see that the voltage, is, let's see, we're using the point, let's see, it's not even a constant. So the, you're just changing the voltage, and then and measure the output voltage and the current. Same thing for LED, bicolor LED. And because we're not doing, in the lab, you'll be able to see the color, but now since you're going to process the data, so you do not have to answer the question whether, what color when you apply the positive voltage, and what color is going when you apply a negative voltage. So basically, the bicolor has the green and red, and depending on so there's a forward current or forward voltage that will change the color, okay, of the LED. So you do not have to indicate which color for what for positive voltage or negative voltage when you apply the voltage. So once you have the data, then you will use the data to plot voltage versus current. Okay, so that's basically what you want to do. So altogether, you should have four figures, one for each electronic device, and then you would do a line fit if it is linear. If the figure is a linear, if the figure is non-linear, then of course you do not have to do a line fit, because the line fit is for linear relationship only. Okay, so all of these four electronic devices there's only one that obeys Ohm's law. The other three were not, they are non-ohmic. So you do not have to do a line fit for non-ohmic material. You only need to do a line fit for the one that looks like a straight line. Okay. All right. So let me show you the data. So of course, like I said, the data, you will go to the lab data folder and then download the data, and the data will look like this. So if you look at the tab, let me just use it small. Okay. So if you look at the, let me just bring this. Can I bring this? No. Can I do this? All right. All right. I don't know. Let me see. Okay. All right. Okay. So if you look at the data, you will see that under this is the data for resistor. And we click on the light bulb. These are the data for the light bulb. And click on this. This is for the diode. And this data set is for the LED. So for each data set, you should have a figure. Okay, so this voltage and the current, you have the current, you have the voltage, and you just do the plotting, and then see if you need to do a line fit, and then determine the value of the slope. Okay, and then for the light bulb, you do the same thing. And if it is linear, then of course you do a line fit. If it is not linear, then you do not have to do a line fit. Okay, and so you're given this 4 data sets. You should have 4 figures. One of the figures should have a line fit with a slope, and that can be compared to the theoretical value. In fact, okay, so you're going to figure out once you will do the once you have finished the plotting, then you will know which one has a slope, and then which value to that you use to do the comparison. Okay, all right. So that's basically a very simple experiment to do for Ohm's law. You just have 4 sets of data, and based on the 4 sets of data, you want to plot voltage in the vertical versus current in the horizontal, to find out which one is ohmic and which one is non-ohmic. For the one that has that is ohmic, you want to do a line fit and use the experimental value of the which is the experimental value of the resistance. You want to compare to the theoretical value of the resistance. Okay, alrighty. So that is it.